Hey guys, in this video the brilliant Mr. B is going to be taking you through expanding brackets for further maths. Now this can be for further maths GCSE, level 2, further supplementary additional qualification, I think that's it, or if you just want to get a head start on your A-level maths. Now there are loads more questions for this available over on my website if you really want to make sure that you are prepared.
We are going to have a look at expanding brackets, starting off with one set of brackets, then two, then we're looking at as many as 5 or 6 set of brackets. So starting off with one, what this expression actually means is that we have 2 multiplied by the bracket x minus 2. So when you have a coefficient in front of the bracket, a number like 2, it's a multiplication. And so what we need to do is we need to multiply the bracket by 2. Now, a common mistake here is just to write, okay, times it by 2, 2x minus 2. And what's happened here is only the first part of the bracket has been multiplied by 2. Now, what needs to happen is that both parts of the bracket, or even if there's 3 or 4 terms in the bracket, every term in the bracket has to be multiplied by what's on the outside. So 2 times x is 2x, that's correct. But then we do 2 times negative 2, which gives us negative 4. And that's our answer. Both things inside the bracket are being multiplied by the term on the outside. So let's take another example. We have a coefficient on the outside of the bracket, and that's being multiplied by everything on the inside of the bracket. So we've got that hidden multiplication sign. So we do x multiplied by x, which is x squared, and then we do x multiplied by 7y. Now the way to do this is look at the sign first, then look at the numbers. We've got 1x and 7y. 1 times 7 is 7. Then look at the letters and just write all the letters in the end in a row. So we've got an x and a y. So there's our final answer. For the next question, we have 2 parts of the coefficient outside the bracket. We have 7 lots of x. So we have a left-handed number. And again, that's being multiplied by everything on the inside of the bracket. So I'll do one term at a time. We'll do 7x multiplied by x. So look at the numbers first. 7 times, and that's a 1x, so it'll just be 7. 7 times 1 is 7. If there's no number, it'll be a 1 you're multiplying by. Then look at the letters. X times x. We're going to have 2 x's. And we could write xx, but that's not the neatest way to write it. If you've got 2 x's multiplied together, we'll write x squared with a power showing how many we have. Then multiply it by the final term in the bracket. So again, numbers first. 7 times 2 is 14. Then look at the letters. Now we only have 1, the x on the outside, so pop that on the end. And there is our answer. In the next question, we have 2 sets of brackets, which makes things a little bit more complicated. So our first bracket is 2 lots of x minus 4, and our second bracket is 2 lots of x plus 6. Now, like before, there's a hidden multiplication sign in the middle. We are multiplying the 2 sets of brackets together, and we have to multiply everything by everything else. Here's the best method. We're going to do 2x times 2x first. Do the numbers first. 2 times 2 is 4. Then do the letters. X and x, we have 2 lots of x, 4x squared. Then that 2x, we also need to multiply it by the second term in the second bracket. Do the numbers first. 2 times 6 is 12. Then look at the letters. Well, we only have an x in the first term, so put the x on. What we don't do, we're not going to multiply the 2x by the negative 4. We're not going to multiply inside the same bracket. The 4's been taken away from the 2x. It's not been multiplied. We're only multiplying the brackets together. So we're multiplying by the things in the other bracket. From the 2x. Let's do the negative 4 next. So we'll do negative 4 times 2x. The numbers first. Negative 4 times 2 is negative 8. Then do the letters. We have an x in there. Let's pop that on. And finally, negative 4 times 6. That's going to give us negative 24. And now what we've done is we've multiplied everything in the first bracket by everything in the second bracket, and you're going to get 4 answers for a double bracket like this. The final thing you can do is you might notice that the middle 2 terms, we have 12x and 8x, they're both kind of in the same format, they're both x terms, and you can simplify those. 12 take away 8 is 4. That will give you 4x. So 12x take away 8x is 4x. Now we have the 4x squared, and with the negative 24. Now, we can't do any further maths here because all these now are different kinds of terms. So we've got an x squared, an x, and an integer, and they are not going to mix together. We can't add those together. So that is our final answer. 4x squared plus 4x, take away 24. Moving on to the next question. Again, we have two sets of brackets. We have 3x minus 1, and that's being multiplied by 2x plus 5. So multiplying everything together, start off with 3x and multiply it by the 2x. So numbers first, 3 times 2 is 6. Then the letters x and x, we've got two lots of x. And just draw the little arrows just to help you keep track of what you've done. Then we'll multiply the 3x by the 5. Numbers first, 3 times 5 is 15. Then do the letters, we've got an x. Now doing the 3x, we're going to do the negative 1. Again, I'm going to multiply it by both. So negative 1 times 2x, numbers first. Negative 1 times 2 is negative 2. And we have an x. Then negative 1 times 5. Negative 1 times 5 is negative 5. Once you've got 4 answers, you know you've finished. But just make sure that you add together the middle two terms because they both have an x on, so they can be collected. So 15x take away 2x is 13x. Also bring down the number at the end and the squared answer as well. And you should have 3 terms in your answer. And I've got 6x squared plus 13x minus 5. Now, for the last one of these questions, hopefully it's even pretty easy now. We've got 3x take away 6 multiplied by x take away 5. So we're going to draw a little x at the top. So the first number in the first bracket, the first number in the second bracket, 3x times x is 3x squared. Then the first number in the first bracket by the second number in the second bracket. 3x times negative 5 will be negative 15x. Moving on to negative 6. The second number in the first bracket multiplied by the first number in the second bracket. Negative 6 times x is negative 6x. And then the second number in the first bracket multiplied by the second number in the second bracket. Negative 6 times negative 5 is a positive 30. Remembering that a negative times a negative is a positive. The middle two terms will collect together, and that leaves us with 3x squared. Negative 15 take away another 6 will be negative 21x. And then we add on the 30. So hopefully that's looking pretty clear by now. Now, before we move on, what happens if we have 3 brackets? So let's have a little look at that. So let's say we start off the same thing. 3x minus 6, x minus 5. Let's keep it nice and simple for the final bracket. What if we had x plus 1? So what do you do with 3 brackets? Well, the first step is to pretend that the final bracket doesn't exist and you only multiply together 2 brackets. So you multiply together the first 2 brackets and we've already got the answer. It's what we just worked out. So we've got 3x squared minus 21x plus 30, but then all of that needs multiplying by the third bracket, x plus 1. So we just do sets of 2 brackets at a time, basically. And now we're going to do the last bracket. Now, we can use the same method we were using above. So what we can do is we can say, okay, we're multiplying 3x squared by the x. And that will give us 3x cubed. So a squared and another x will just raise the power up by 1. And then we're going to multiply that by the 1 as well. So that will give us 3x squared. Because you multiply it by 1, it's going to stay the same. Then we can move on to the second term, the negative 21x. So we're going to multiply it by x. That'll be negative 21x squared. And then multiply it by the 1. And that'll just make it stay the same, negative 21x. Finally, we'll look at 30. Do 30 times x. That'll be 30x. And then 30 times 1 is 30. And now we've got a long list of terms here. Some of these can be collected together. So which ones? Well, the x squared terms could be added together and the x terms can be added together. And then this will lead into our final answer. So we're going to just do one power at a time, starting off with x cubes. We have 3x cubed. Now let's look at the x squareds. We have 3x squared take away 21. So we've got negative 21 and you add on 3. That's going to give us negative 18. So negative 18x squared. Then we'll look at x with a negative 21 and a plus 30. So 30 take away 21. You'll notice I'm just doing these the other way around. It's easy to work out that way. 30 take away 21 is 9. So that's plus 9x. And at the end, we've got the plus 30. So now we should be confident with the double brackets. So that's a quadratic answer with a squared sign on the x. But we've got 3 sets of brackets. Just understand it's exactly the same method. You have an extra step at the end. Do the first 2 brackets, get an answer, and then multiply about that answer by the 3rd bracket. So we've looked at 1, 2, and 3 sets of brackets. What do we do with 4 and 5 sets of brackets? Now, the first thing we're going to do here is going to try using the method we've used so far and see if that works. And then we might look at a shortcut. We have 2 plus x, and the little 4 means we have 4 sets in this bracket. But all we need to do is just do one at a time. So let's just do 2 plus x and another 2 plus x and multiply that out. That'll give us 2 times 2 is 4, 2 times x is 2x, x times 2 is 2x, and x times x is x squared. So collecting all the terms together, x squared terms first, we have x squared. Then the x terms, we have 2x and 2x, which is 4x. And then those numbers on their own, we've got a 4. So that's the first 2 brackets done. So what we need to do now is take our answer, x squared plus 4x plus 4, and we need to multiply that by another 2 plus x. So x squared times 2 is 2x squared. X squared times x is x cubed. Then we have 4x times 2 is 8x, and 4x times x is 4x squared. Then we have 4 times 2 is 8, and 4 times x is 4x. So now collect up your like terms. So again, just start off with the largest power. So we'll look at the x cubes first. And we only have one x cubed term, so we can write that down. We have x cubed. Maybe we can cross these off as we go this time so we don't miss any out. Then let's look at the x squared term. So we have 2x squared and 4x squared. All together, that's 6x squared. Then look at the x terms, 8x and 4x is going to be 12x altogether. And then we've got the 8. So now we've multiplied together 3 of the brackets. So now we follow the same step. We take our answer so far, x cubed plus 6x squared plus 12x plus 8. And all of that has to be multiplied by our 4th bracket, which was another 2 plus x. So same method, x cubed times 2. That's 2x cubed. X cubed times x. That's x to the power of 4. Then we have 6x squared times 2. So if we double it, we'll have 12x squared. Then 6x squared times x. So you times by x, put another 1 on the power of x, 6x cubed. Then we have 12x times 2, which is 24x. 12x times x, 12x squared. Then 8 times 2 is 16, and 8 times x is 8x. So now we have a really long list of terms. Our little arrows now working out, it's getting quite messy there. So this isn't an ideal method, but we can get our final answer. Start with the largest power. We have x to the power of 4. Then the cubes, we have 2x cubes, 6. We've got a 2 in the 6. That's 8x cubed. Then look at the squares. We've got 12 and another 12. That's 24x squared altogether. Then look at the x terms, 24 and 8. That's 32x altogether. And then we've got a 16. And since I've crossed them all out, I know that I've finished my list. 2 plus x, all to the power of 4, expands to x to the power of 4 plus 8x cubed plus 24x squared plus 32x plus 16. So we can do it using this method. It's not the worst thing ever, but the next 2 questions are going to be to the power of 5, so it'll be one more step. So can we do this a faster way? So when we look at something that's to the power of 5, we really don't want to be using the method we've been using so far, so we take a lot of steps. So what can we do? Well, there is a pattern in the way that we expand brackets. So, for example, we're looking at 2 numbers in a bracket, squared. Now, the pattern when you do this is that you can have your x squared term, then you get 2 terms in the middle, that add together, and then you have your two numbers that multiply together as well. So you can express it looking like this. So imagine the a's are where your x's are, and the b's are another set of numbers. So when you have two numbers and the brackets are cubed, there's another kind of similar pattern to this. And you're going to have a kind of an x cubed term. Then you're going to have some squared terms that add together and simplify. And then you've got some single x terms, and then you've got your numbers. And you can express it like this. And if you're not sure about this, what you can do is just try expanding brackets with a and b and multiplying a's and b's together. And this is what you're going to come out with. Now, here's the pattern. What if we work backwards? What if we had a plus b, but it was only to the power of 1? Well, if it's the power of 1, it's going to stay the same. So you're going to have a plus b. You're going to have one lot of a and one lot of b. What if we had a plus b to the power of 0? Well, if you remember your laws of indices, anything to the power of 0 is 1. And what you'll see is, as you expand this, you get this kind of triangle pattern, and this is called Pascal's triangle. Now, we have some brackets to the power of 5, so we want to continue this downwards to the power of 5. So the next row would start off 1a to the power of 4, and the row after be 1a to the power of 5. And hopefully you can see that this entire row coming down diagonally here, we've got a squared, a cubed, a to the power of 4, a to the power of 5. So the power on the a is going up each time. What about the rest of this? Well, the last term is going to be the same, and the final term, we are going to have a 1b to the power of 4 and a 1b to the power of 5, which is meaning in most of these brackets, you kind of your whole number, 5 of those being multiplied together. And again, look at the powers. Power 0, we've got 1b, 2b's, 3b's, 4b's, and then 5b's. So we know what the start and the end is going to be like. Now, what about the other patterns here? Now, the way that a triangle works is that each kind of brick in this pyramid that I've just drawn is the ones above it added together. So if we look at the 3a squared b, above it, you can see a 1a and a 2ab. So the 1 and the 2's become 3. So as you go down this, the next term, you have 1a to the power of 4. Next, it would be a 4. Because above it, we can see a 1a cubed and a 3a squared b. So the 1 and the 3 makes 4. Then the coefficient on the next one will be a 6, because above it is a 3ab and another 3ab. And then the one after that will be going back down to 4. So then on the next row, we have 1 and 4. 4 and 6 is 10. 6 and 4 is 10. And 4 and 1 is 5. So this is how you build up the pattern. Then let's look at the a and the b's. Well, on the top row, we've got 2ab. Then below it, we've got a squared b. Then it must be a cubed b and a to the power of 4b. And the same on the other side. You've got ab squared, ab cubed, and ab to the power of 4. What about the middle sections? Well, look at the kind of pattern as you go across. We've got 2 a's, a, b, and then 2 b's. And below that, we've got 3 a's, and 2 a's and a b. 1a and 2 b's, and then 3 b's. So it's kind of like, as you go from the left to the right, the a's go down and the b's go up. So on the row, we've got a missing one with a 6. We've got 4a cubed, so after it'll be a squared. And then the b will become b squared, that'll go up. We do the same with the bottom row. So the a's will go down and the b's will go up. The a's will go down and the b's will go up. So using these patterns, this is how you construct Pascal's triangle. And looking at our question, we've got two numbers in a bracket and it's to the power of 5. So that's what we're going to be working with. So if you can construct Pascal's triangle, we now have an expression we can use to help us solve this. So how do we use it? Firstly, we're going to write down the expression. A plus b to the power of 5 is equal to 1a to the power of 5 plus 5a to the power of 4 plus b. So just notice how the a powers are going down, then 10a cubed, and then your b, and the b is going up, and 10a squared, the a is going down, the b is going up, then a 5, the a is going down, the b's are going up, and then 1, the a's have gone to 0, and the b's have gone up. So you can almost figure out the powers without drawing the full triangle. It's just the coefficient, the 1, the 5, and the 10 that you're going to either work out or remember. On the next question, we'll go through how to do this without drawing the full pyramid. But for now, how do we then get our answer from this? Well, we need to work out what A and B are. So when we look back at our original question, the 1 and the 3x inside the bracket, they're going to correspond to A and B. So every time we see an A, we're going to replace it with a 1. So let's go through and replace all the A's with a 1. I'm just writing them directly underneath, so I know I'm not going to miss anything out later on. Then with the B's, we're going to replace those with 3x. Now, I think I will do this in a different colour. So every time I see a B, I'm going to write 3x. And what you want to do is just contain it in brackets, because both parts of 3x need to be squared here. So again, every time I see a B, write down 3x in brackets and the power. And now we've substituted, we just need to write in the parts of the expression that don't get substituted. So the constants. So it's equal to 1 multiplied by, and then 5 multiplied by. And you'll notice some new terminology here. Rather than writing a multiply symbol, a time sign, that might get a bit confusing. So I'm just doing a little dot. And a dot can be used as a simple, unobtrusive way to show it's a multiplication without having to write an X, which could be confused, with the X term in algebra. So now I've done this, we now need to kind of resolve every single term here and figure out what they represent. So our first one, I think I'll just underline these one at a time. We are starting off with this term, and it's 1 multiplied by 1 to the power of 5. Well, that's going to be 1 times 1 times 1, so on. Multiplied by 1, it's going to stay the same. This is going to be a 1. Now let's look at the second term. So we have 5 times 1 to the power of 4, and then we have 3x. So that's what we're multiplying together. Everything's being multiplied, so using big maths, we can just, not need to do it in a certain order. So 5 times 1 will give us 5, and then 5 times 3x will give us 15x. Now let's look at the third term. So again, the 1's being cubed, multiplying 1 will get you 1. We don't need to look at that. So we've got 10 times 1 is 10, then 10 times 3x squared. Now, we didn't just use big maths here. We need to square the brackets first. So 3x squared, we are going to get an x squared term out of this, but we also need to square the 3. So 3 squared is 9. Multiply it by the 1, still 9. Multiply it by the 10. That will give us 90. Let's then move on to our next term. So again, we need to use big maths, so we need to look at the brackets first. It's cubed, so we know our x term will be cubed. But we also need to cube the 3. So 3 cubed is 27. 27 times the green 1 will still be 27. Then 27 times the blue 10. That'll be 270x cubed. So you'll see these numbers are getting out of control fairly quickly, aren't they? But we only have 2 more to go. Let's look at the next term. Again, start off with the brackets. Make sure you're using big maths. The x term is to the power of 4. But the 3 also has to go to the power of 4. Now, what this is going to give us is 3 to the power of 4. You can work that out on a calculator if you like. It's going to give you 81. Multiply that by the 1 to the power of 1. It'll still say 81. And then multiply it by the 5. And that gives us 405. Then moving on to the last one. Now, again, the x term is the power of 5. So the x to the power of 5 there. But what about the number? Well, the 3 in the bracket is also to the power of 5. That's going to give you 243, but we're only multiplying it by 1. So we can leave it as that. 243. And now we have our final answer. We have 243 x to the power of 5 plus 405 x to the power of 4 plus 270 x to the power of 3 plus 90 x to the power of 2 plus 15x plus 1. So you have a choice here. You can do it like the previous questions, and you can have 5 steps. We do 5 sets of multiplications and collecting like terms. And it's going to fill up the whole page, and that's one option. The other option is using Pascal's triangle. Now, if we ignore the triangle itself, if we just look at the work we've done at the bottom here, it's only 3 lines. It's a lot more substitution, though. So you kind of have to make a choice. Are we going to do lots of multiplications and collecting like terms, or are we going to be doing a brief calculation of Pascal's triangle, which I'll show in the next question, and then some substitutions? What you'll find is, as you get higher and higher powers, 5 is the smallest power you're going to get in a question like this. You could get power 8 or power 9. So eventually, you'll have to be doing the triangle method like I've just shown you here. But let's try and speed it up now. So let's have a look how to do a Pascal's triangle question quickly. So firstly, to generate the coefficients in the triangle. So you start off with 1 at the top. Then the next row, it's the rows above it added together. So it's going to be 1 and 1, because the only thing above it is a 1. But for the next row, we're going to have 1s at the edges, but in the middle it's going to be a 2. because the 2 is the two numbers above it to the left and right added together. So the next row, you're going to start off with 1s, but then we're going to have a 3 and a 3. Because above the 3s, we've got a 1 to one side and a 2 to the other side. So then we're going to have a 4, a 6, and a 4. And then we're going to have a 5, a 10, a 10, and a 5. And each number is the two numbers directly above it to the left and right added together. Now, our expression here is the power of 5. So which row are we looking at? Well, it's not the fifth row, you'd be surprised to think. We have row 0, 1, 2, 3, 4, and then 5. So you always start off with row 0, because anything to the power of 0 is 1. So always keep that in mind when you're choosing which row to look at. So I'm just going to shade in. This is the row we're looking at. We're going to choose this row. 1, 5, 10, 10, 5, and 1. So now I've worked out the coefficients, we need to write out the expression. So it's going to be a plus b to the power of 5 is equal to, we just go through each coefficient one at a time. So we have the 1, and we'll start off with a to the power of 5. Then the 5 and a to the power of 4. And all we're going to do is, as we go through each coefficient, a is going to go down and b is going to go up. So we're going to have 10 and a is going down again. B is going up again. Another 10, A is going down, B is going up. We have a 5, A is going down, and B is going up. And then a 1. So now the A is down to 0, it's gone, and B is up to 5. So I fairly quickly generated the entire expression for that row of Pascal's triangle. So it doesn't really take as much work as I showed you on the previous question. It only took me about 2 minutes to do this, and now we can substitute. So what is A and B? Well, it's going to be the 6 and the negative 7x. So now we substitute. Every single time you see an A, we're going to swap it with a 6. And every time you see a B, you're going to swap it with negative 7x. And the way to do that, since there's multiple elements to this, do it in a bracket. If it's just a single number like 6, that's fine. But something like negative 7x, do it with a bracket. So every time I see it, let's just color code it. So I'll choose another color to do that in. Let's not do it in green. So negative 7x. Let's look for the b's, open a bracket, write it in, close a bracket, and do that for every single one. But then remember, they're going to have increasing powers on them. And the last thing is go through the list and write in all the things that didn't need to be substituted. It's like the 1. And again, they're being multiplied. You use a little dot to show its multiplication rather than confusing yourself with another x in there. So fit it in best you can. And there we go. So now we've substituted, we'll just need to work out our numbers. So let's take each term one at a time. We've got 1, 2, 3, 4, 5, 6 terms to work out. So looking at the first term. So we need to do the indices first. 6 to the power of 5. This is going to be quite a large number. I'm going to work it out in a calculator. 6 to the power of 5 is, so I've got 7,776. It's been multiplied by 1, so it's going to stay the same. Moving on to the next one. We've got all, I'll ignore the x for now, so pop that on the end. So we've got a negative 7 in our brackets, and negative 7 is being multiplied by 6 to the power of 4. So we'll work out the indices first. 6 to the power of 4 is 1,296. It needs to be multiplied by the negative 7 and the 5. And that's going to give us, and it's negative, so we need to get rid of that plus symbol I wrote in. So let's not write those until we're sure. Negative 45,360x. Now let's move on to the next one. Again, remember to use big maths, we need to do the brackets first here. So let's look at the numbers first. We have negative 7 in brackets, and it's the power of 2. Negative 7 times negative 7 is 49. Multiply 49 by 6 to the power of 3, and then multiply it by 10. And that's giving me, that's a big number, 105,840. Now, just to show you how I'm going to write that in my calculator, this is what I wrote down. So on the calculator, I just wrote brackets, negative 7 squared, multiplied by. I did some more brackets and did 6 to the power of 3, and then I times it by 10. If you type it into your calculator like that, you should be getting the correct answer. So just be careful how it goes into your calculator. If you're not confident, just do it one step at a time. Work out the 49, then work out what 6 to the power of 3 is. That's 216. And then you can do a simpler multiplication with less scope for your calculator to make a big mass error. Anyway, once that has been worked out, we need to put the x on the end, and this will be x squared because the x was in the brackets with the squared symbol. Looking at the next one, so brackets first, -7 cubed. That gives me -343. We're multiplying that by 6 squared, which is 36, and then we're multiplying it by 10. That gives -123,480, and it's going to be x cubed. So remember the ascending powers of x, we go through this. So we're getting quite large numbers here. Let's move on to the next term. So we have a -7 in brackets to the power of 4. That's going to give me 2,401. Be careful that your calculator doesn't give you a negative answer there, because what it might do is add the negative symbol on at the end, where it should be -7 multiplied by -7 multiplied by -7 and -7. So what you can do is you can put -7 inside brackets, like it is in the expression, and put the power 4 on the outside of your calculator. We'll multiply that by 6 and by 5, and that's going to give us positive 72,030. So numbers are getting smaller again. That'll be x to the power of 4. Then we'll look at the last one. So -7, put that inside brackets, put it to the power of 5, and we're only multiplying it by 1. That's going to give us -16,807 x to the power of 5. And that is our final answer. You can see that's it's a really long expression. We have some giant coefficients on the numbers. The big thing to kind of learn here is that with larger powers like 4s and 5s especially, you are going to be getting really, really large numbers. They do get control very, very quickly. But there's our final answer. So you can see what we need to do is we have a quick sketch of Pascal's triangle, and we choose the correct row. Then we write out the expression with ascending powers of b and descending powers of a. And then we substitute. Then using our calculator, we're very, very careful. We use BIDMAS, do the brackets first, do indices after, and our multiplications last. We just work through it very carefully, step by step, doing our substitutions.
Ouch. Love you too, Prim.